Hi, my name is Jerome Savaramutu, and this is my serial dilution video. So the dilution type that I'm going to be doing is a 1 in 10 dilution. My sample volume is 10 milliliters, and my amount to be transferred for each dilution is going to be 1 milliliter. And so I have these claims mathematically proven down here with the C1 V1 equals C2 V2 calculation. And you can see that our original concentration of 100% multiplied by our original volume that's going to be moved over each time, which is 1 milliliter, is equal to our new concentration, which is going to be 1/10 of the previous, multiplied by our new volume, which is going to be a total of 10 milliliters. So 9 milliliters of water plus 1 milliliter of the previous. I have another calculation down here showing the number of colonies for our least diluted but still like readable plate, which we're going to say is 100 multiplied by our dilution factor for that plate. And that's going to give us the total amount of colony forming units where the like if you had a milliliter or whatever amount plated of your undiluted sample, this is how many colony forming units would be in there. And then we're going to process that a little bit more, and we're going to multiply this by the volume of the sample over the amount smeared, and that's going to give us the total amount of colony forming units in our original sample. So I'm now going to perform the serial dilution. So I'm going to take a clean pipette with 1 milliliter of juice, and I'm going to pour this into the 9 milliliter of water over here, and then I'm going to rinse this out in the sink or like some faucet or something, and it's just a water bottle, but pretend it's a sink. And I'm going to come back here. I forgot to make sure it's mixed around, so I'm just going to mix it around real quick. Forgot to do this earlier. Normally you'd like suck it up with the pipette or something, but I forgot to do that, so I had to do that real quick. And I'm going to suck up another milliliter, move it over to here, mix it around, and then clean out the pipette again. So this process repeats all the way down from your sample, your original with a concentration of 1 to your concentration of 0.1 to your concentration of 0.01 all the way down. And the reason why we clean the pipette after each move down is because if you say like hypothetically you had 100 waters in here and 1,000,000, or if you have 100 juices in here and 1,000,000 waters, and you accidentally put 10 more juices in here than what you were supposed to have, that's a 10% error. But if you put 10 more waters in here than what you're supposed to have, that's like not even a percent of error. And so the amount of juice is very like finicky.